I'm going to give you a different perspective, pero primero Don Iván dio su charla en español con pocas palabras de inglés y yo en inglés con pocas palabras de español. But I'm going to give you a different perspective than anything you've seen so far. The perspective you have seen is from the perspective of an engineer. I want to talk about what Don Iván talked about, which was the perspective of the market, because it's who you're selling to, not who you're selling from. You've got the technology, what do you do with it? The problem is we engineers, I'm also an engineer, I have a ring to prove it, I'm the magic ring. I understand this perspective, but it's the wrong one. Do you know what an engineer is? Everyone knows what is an engineer? I'm going to give you a definition of what an engineer is. So during the French Revolution, the terror, they were cutting off the heads of almost everyone. And during this terror, 3 people were to be put to death. A lawyer, of course. I'm sorry. My brother's a lawyer, but I haven't killed him yet. A lawyer, a priest, and an engineer. And first, the priest goes up the steps and they read the reason for his death, that why he must be killed in the name of the revolution, the sainted revolution. And he puts his head in the guillotine, because you use the big cutting blades. Puts his head in the guillotine, and they explain why he's going to die, and they pull the rope, and the blade comes rushing down, and stops above his neck. And he jumps out and he says, "Whom God has given life, you must set free." So they say, "Oh, that sounds good," and they send him home. And then the lawyer rises up the steps and he puts his head into the guillotine, and they read the condemnation. And they pull the cord, and the blade comes running down, and it stops just above his neck again. And he jumps out and he says, "It is the law. You have only one opportunity to put me to death." All the laws are new. They're looking through, yeah, that's right. We have to send him home. So they send him home. The engineer walks up the steps and he puts his head in the guillotine. And he says, "Wait, wait, wait. I think I see the problem." Don't be that engineer. Don't be that engineer. So I'm going to give you some engineers' perspectives. Anybody ever heard of this guy, William S. Gates III, Bill Gates? Anybody heard of him? Is the richest man in all of Seattle, Washington. And the state of Washington and the United States and the whole world. In 1995, he made a very famous statement to the press. They asked him, "Why don't you have an internet division?" And he said, "Why would I have an internet division? It's like having an electricity division. It's something I would do anyway." Now, at the time, I was reading about the history of the adoption of electricity in the United States and in Europe between 1900 and 1910. I don't know how many of you know this, but between 1900 and 1910, Colgate-Palmolive and Royal Dutch Petroleum, and every big company had an electricity division. Why? They had an electricity division to understand how to use this new technology to change their companies. Colgate-Palmolive, how to manufacture better, how to distribute better, how to market better, how to understand their customers better. They had an electricity division, and now it's gone. No, it's not gone. Those guys are now called janitors. Yeah, they clean around the electrical equipment. It has changed, but it's been 100 years. Anyway, he said this in 1995, and in 1999 he said this instead. He wrote a letter to all of his employees. It's a command and control company. The CEO writes a letter to all of the employees. And he said, "The internet changes everything." Everyone agree with that? Everyone agrees with that, right? Okay, you're all wrong. This is what you're thinking about when you say the internet changed everything. The things we have been talking about, the internet has changed. And the top picture is music, and it already has been some conversation about that this morning. You know, that's called a boombox on the left side. Some of you, like me, don't have hair on top. You remember the boombox. The rest of you do not. But we used to have music as a physical thing, like the Feria de Discos, right? Not anymore. Even though I wear a suit and a tie, I actually download music, but always legally. That was serious. So that has changed completely. We listen to music now on computers. The computers don't look like this computer. They look like, they typically look more like, well, I mean, I'm sure you're all carrying one. This computer. This is called a BlackBerry. I'll explain later. I mentioned I'm old and wear a suit, right? I have to carry a BlackBerry, it's required. So watching movies, I just discovered, by the way, that my children, 24 and 27 years old, did not realize that you can watch television over the air. Nor do they have cable television. They always watch shows from the internet, legally, mostly. Sometimes YouTube upside down, and I don't know if you've seen those. But anyway, so that market has changed. The newspaper market has changed. I actually know the people that run one of the largest newspapers here in Chile, and they were very quick to go electronic, as I'm sure you know. EMOL, the Mercurio Online is very successful. But newspapers in the United States are gone, almost gone. In the city I live in, Boston, there are 2 newspapers. They're both 3 pages long. They charge a ridiculous amount. I don't get them. I read the news every day, but I don't read it with newspapers. The sole purpose of a newspaper now is to transfer ink to your fingers. These markets have changed. What's the same about these markets? These markets are all about entertainment and information. They were the easy markets to move from atoms to bits because it was already bits, it was already information. Information is easy to move electronically, but these are not the majority of the worlds that can be changed. Anybody know what this machine is? Somebody recognizes, please, somebody recognizes this machine. Yeah, you do. You're lying. This is a Modicon 584 programmable logic controller. The short name is PLC. It's was used for in 1980 when I was working on it. I was 3 years old. I was a child prodigy, yeah. It was used for managing what's called discrete manufacturing line, making things. You know, there still are industries where they make things. So making, the particular group that we worked with was making disc brakes for cars outside of Detroit, Michigan, which is a place where they used to make cars many years ago. That was supposed to be funny, sorry. The company was called General Motors, but they gave us lots of money because they had lots of money, so we called them Generous Motors. I said General Motors, yeah, sorry. Anyway, this is basically a computer. Inside, in 1980, was a Motorola 68,000 chip. And many computers in 1980 had 68,000 chips inside. This one, however, was different. It didn't have a screen, it didn't have a printer. The purpose was to control that manufacturing line. So even though it was a computer like any other computer in 1980, it had different interface, and in fact, this is the programming language. Anybody know that programming language? You're supposed to know that one, yeah. It's called ladder logic. And that's how you programmed it. It basically says do this, and then do this, and then do this, and then do this, one thing after another, as the part moves down the manufacturing line in the discrete manufacturing system. By the way, people still do make things. And so these are still used. I'll show you one in a moment. The other interesting change from the way things are today is this was not connected to any of the other computers in the plant. So if you wanted to know how much supply you need, or how much you're going to generate today, or what's coming through the manufacturing line, you could take information from this box, print it out, walk across the floor to your computing systems, what were then called manufacturing resource planning, now called enterprise resource planning, and type them back in. And people did that. In the plant where we were working, they unfortunately had a very low error rate, only 40%. There were plants where it was higher. So it's a computer, but it's not a computer connected to the rest of the world. There was networking in 1980. I know it sounds like a very long time ago to some of you, but there was networking. There was the thing before the internet. There were many of them in where we were. It was called the ARPANET. But there was no network connection on this device. Fast forward 36 years. Fast forward slowly, there we go. Fast forward 36 years, okay, 35 years to 2 weeks ago. That's what the box looks like now. It's the same company, although it has been bought and sold many times. Modicon was sold to Gould, was sold to this company. Anyway, it's now called Schneider Automation. It is a French company with a German name in the United States. That's not supposed to be funny, that's just true, and you're supposed to learn from that also. It's something international. It is still true that the way you program it is this weird language that only he knows. So you should all hire him today. And it is still true, worse, although it has a network connector, it doesn't connect to the internet. So if I want to take information from this box that's controlling my factory, I print it out and I walk across the floor and I type it into my enterprise resource planning system and I hope that the data is still good. This is crazy. There's a complete split between operational systems and information systems. And we've seen that in the 2 presentations we saw this morning also of startups. Their whole idea is to take operational systems, for example, Mario's system with farming, take operational systems for managing the farm and the weather around the farm and so forth, and connect it to the information systems. That's the big change, and that's a huge opportunity. I'm not going to talk about too many. I could talk about the energy grid. I won't talk about the Chilean energy grid, which was designed in 1637, maybe 2 years later. But if you think that's bad, you should see the energy grids in the United States. The energy grids, there are 3 energy grids in the United States. Does anybody know what they are? Oh, this is so funny, but it's true. East, West, and Texas. And they were literally designed in 1950, and they were designed in a time when there were a small number of energy manufacturers, power plants, and millions, tens of millions, hundreds of millions of energy users. That's not true anymore. Today, you have energy manufacturers everywhere. We have solar panels on the roof. We have windmills. Here in Chile, you should have geothermal power systems, but it's amazing how few you have. By the way, I'm building now in Puerto Varas. You drill down just a few meters, it's 27 degrees. How am I going to heat my house? I'm going to pump it out of the earth and into my floor. That's it. 2-year payback. But we're not redesigning the power grids to deal with that. Another example, jet engines. We only get information from jet engines typically when the jet lands. Enormous amounts of information is collected by the jet engine. We know how much air is going through the high bypass section of the engines. Do you know about jet engines too, sir? He finally tells the truth. Anybody in jet engines? Nobody? So there's the compression, the efficiency of the compressors, and the amount of air going into the compressors, and the amount of propulsion, and the amount of fuel that's used. All these things are measured. So when a flight takes off from Santiago and lands in New York, it lands with upwards of 10 terabytes of data. And that data then eventually goes to the maintenance base for the airline, who says, well, maybe if we replace the 3rd stage compressor, blade number 57, we'll get a little bit more efficiency out of the system. But they don't do that. And today, the way you got information in 1960 from a jet engine was you plugged a cable in, downloaded it, you looked at the data if you had the time, and maybe did something with it. The only difference is today you might use a USB key. It has not changed. It's amazing how many markets in which there has not been a connection between operational technology and information technology. In the rail space, I had the opportunity to talk to one of the senior executives at General Electric in their transportation systems group. They make enormous diesel electric engines, big rail engines. And he said, we now collect on those rail engines 9 million points of data every second. And I said, how much of that data is actually used? He said, 3. I said, 1/3? That's not so bad. He said, no, 3. They throw away nearly all of that 9 million points of data every second because they don't have a way to store it and they don't know what to do with it. In smart homes, we've heard a little bit about smart homes this morning. There's all sorts of opportunities, but the real opportunities are in industrial systems. You can call it Industry 4.0. The Germans call it Industrie 4.0. In China, it's called Internet Plus. In the United States, it's called cyber physical systems. We call it Industrial Internet, which is connecting industrial systems to the internet. It's a huge step forward and an enormous opportunity. I'm going to tell you a little bit about that opportunity. But first, I wanted to relate it to the revolutions that we have seen. So you've heard several times about different measures of revolution. I'm going to put it in much simpler terms. Between 1840 and 1900, there was an enormous revolution called the Industrial Revolution. You've all read about the Industrial Revolution. It resulted in an enormous increase in productivity, about between 2 and 4 times, not percent, 2 and 4 times the productivity per person by moving human brawn to machines. Simple idea. First steam, and then internal combustion, gasoline, benzina engines. That was a huge step forward, which also created an enormous disruption. Have any of you read about the Webers in Germany or the Luddites in England? Nobody. There were actually large groups of people that went around destroying these new machines because they were destroying jobs. And we will destroy jobs too. You saw an example already with the taxi cab. This happened again between 1900 and 2000, especially between 1960 and 2000 with the Internet revolution. The Internet revolution moved human connectivity, not intelligence, connectivity, to machine connectivity. That's really what that new economy was about, other than people losing a lot of money in 1999 and 2000. And again, there was an enormous leap in productivity, between 2 and 4 times leap in productivity. Huge jump. And there were jobs destroyed. In many countries, bookstores are nearly dead. Where I live, we used to have 5 bookstores in a town of 30,000 people. We now have 0. And the nearest large bookstore mostly sells toys for children. Most people buy their books online. They read them on these small devices. That market has been destroyed. But new jobs were created. Actually, far more jobs were created than destroyed. My favorite example is in the technology itself. For example, webmasters. Before 1990, there was only one webmaster in the world. His name was Tim. That's not a joke, it's true, I know him. His full name is Timothy Berners-Lee. Now, there are millions of webmasters. This is a job that did not exist only 20 years ago. So more jobs were created, but also, because of the huge leap in productivity, there was a huge leap in consumer demand. That's where the real value comes from. That's why you should be focusing on what value you can give consumers. We think we can do this again by taking the Industrial Revolution and connecting it to the Internet Revolution, connecting operational systems with information systems. And we think we'll see another huge leap in productivity. And we think we'll see enormous opportunities and new jobs created and jobs destroyed. I'm always asked, what is the first market to be changed? And I have one simple answer. I don't know. But I will tell you one that will be irretrievably changed in only 20 years. In an interview 2 days ago, Elon Musk said, if your Tesla car is in California and you're in Boston and you need it, you call it up and it will drive itself to you. That's not the future, that's today. The point is, in a world with driverless cars, where I can call my car and have it come to me wherever I am, the purpose of a taxi driver is to find another job. It's not funny. It's a huge social disruption. Actually, I think that's what government should be focusing on, is how do we deal with social disruption? And the answer is with education. And the answer, what's the technology we should teach? No, we should teach flexibility, because we don't know what's coming. I should say, I've mentioned smart homes. Our focus at the Industrial Internet Consortium is not on smart homes, it's not on Fitbits. How many of you are wearing Fitbits? Anybody? When's the last time you looked at it? 3 years ago, yeah. That's actually the #1 most returned consumer device in the world today, these Fitbit devices. People buy them because they're cool and then they never look at them. There's an interesting market in consumer devices, but there's a huge market in industrial machines. And it's a huge market that is untouched. It's an opportunity that you can't even consider. Let me tell you how big that opportunity is. Here are some examples. These are actually a couple of years old, some of them, about the guesses of how big this opportunity is. General Electric did a report in 2012. It's worth reading. It's freely available on the net. It was written by their chief economist, not their chief engineer, a man named Marco Annunziata. And he said that if you look at the world industrial market, the world GDP, which in 2012 was about 70 trillion, that's $70 million, about, as you see, 46% of that could be affected by connecting to information technology, but has never been. That's $32.3 trillion of GDP every year. It's an enormous opportunity. A 1% swing in $32 trillion is $300,000 million per year. It's an enormous opportunity. Cisco says that will increase the private sector profits by 21% in the next 4 years. Gartner says $300 billion in incremental revenue in the next 4 years, worldwide. McKinsey says $36 trillion in operating cost reduction in the next few years. This is an enormous opportunity, and it's an almost untouched opportunity. You heard about precision agriculture. That's what we call it, precision ag. That is one of those huge industrial opportunities. It turns out people need food. It also turns out, by the way, that Chile grows 50% of all the fruits and vegetables that are consumed in the northern hemisphere during the northern winter. In other words, now. 50%. Imagine what you could do if you could bring down the cost by just a few percent and bring up the yields by 15%. Imagine the opportunity there. It's a huge opportunity. What we have to add is internet thinking. I don't care if you call it Platform Industry 4.0 or Internet Plus or cyber physical systems. What I want you to do is think, how does internet thinking change industrial systems? It's a much larger opportunity than apps for iPhones. I'm not going to read all of these because I don't really have the time. This is just General Electric's estimates of the impact on their products. On the upper left-hand corner, this is from 2012 to 2027, 15-year outlook on savings using Internet of Things technology, industrial Internet of Things technology in their industrial markets, just for General Electric. $30 billion US saved, $30,000 million US saved over that 15-year period, $2,000 million per year, simply by connecting their jet engines to the manufacturer. So how are they going to take advantage of that? I'm going to give you an example at the end. Actually, I think the one in the upper right-hand corner is even more interesting. $63 billion, $63,000 million, $4,000 million per year saved in liability because of medical procedures. What I like about it is also lives saved. There's an enormous opportunity here to change people's lives. So how do we get there? If we do nothing, we are simply hoping that the big data people and the security people and the systems integrators and the software engineers and the mining companies and the banks and the manufacturers will somehow create all of these relationships one-on-one to find a way to solve this problem, to find a way to integrate systems in healthcare, to find a way to integrate systems in jet engine manufacture. We think that's a really bad idea. We think we can create an opportunity for them to work together under cover of antitrust and find a way to bring in the security technology and bring in the manufacturing technology and bring in the banking technology and bring in the mining technology to find a way forward to use internet technology, information technology in integrated manufacturing systems, in integrated jet engines, in integrated financial systems, for example. And I'll give you some examples. We started this March 2014, almost 2 years ago. 5 companies signed up: General Electric, IBM, Intel, Cisco, AT&t. At the CEO level, and they said, we're going to work together. Even though we're competitors, we're going to work together to apply internet technology to industrial systems. And maybe in 2 years, 80 or 100 companies will join us. Today, we're about 250 companies. The organization has 9 offices in 7 countries. The headquarters are in Boston, which explains my accent. Companies are everywhere. You can see the list there. So someone has mentioned Bosch today. Bosch is there. I'd like to mention this small company you might have heard of. People say that Chilean large companies aren't innovative. They were one of the first to join. They are the first mining company to join, the first Chilean company to join. Why? Because they see that there is a way to change the way mining is done. They see that there is a way to change the thinking, how to apply information technology, not only to the information about payroll, but the information about what's going on inside the mine. For those of you who don't think that Codelco is innovative, I invite you to go visit Calama, where they have an enormous 10-meter wide screen and 3D rendering of the mine, so they can do their mining planning completely digitally. And I invite you also to look at their investments in life sciences and biotechnology, Mikomo and Biosigma. It's amazing what innovation happens here that people don't know about. 40% of our members worldwide are large companies, more than 50 million US dollars revenue per year. 55% are small companies. Why so many small companies? Because if you look at a list of companies that's working on an interesting project at the Industrial Internet Consortium, and that list of companies says Bosch and General Electric and Tata Consultancy Services and Fubar Company, which one are you going to click on? It's a huge opportunity to get visibility when you're in the company of large companies. And they bring in technology that other people just don't think about. Operating systems technology, security technology, software services for the electric grid, all kinds of different companies, and they're all over the world, 55% of our membership. The remaining companies are government agencies in about 10 countries. They are academic institutions, and they're testing companies. For example, this one, Underwriters Laboratories, is a company that tests products because they have finally realized the products of the future are going to have software embedded in them. And so they're going to have to figure out a way to test those products, and they're going to be connected products. And there are research organizations, and there are universities, universities all over the world. I'm sure you can all read that, so I won't have to read it to you. You can't? So lazy. Our process is very simple. Bring together the companies, develop use cases. How can we apply information technology to industrial systems? Develop architectures that implement those use cases, and security use cases. How are we going to attack those systems so we know that they are secure? Not how do we secure them, how do we attack them so we can secure them? And then we build what we call test beds, projects, test projects, pilot projects, to show how you apply information technology to industrial systems. Here's the first one that we announced. It was last February. It was announced in Germany. The three partners are Bosch, which I'm sure you know is a major manufacturer of what we call white goods, home goods. They also are a major manufacturer of tools for manufacturing, and they're a major manufacturer of parts for automobiles, typically high technology parts. Don Ivan talked about it for a bit. Tech Mahindra is a large systems integrator based in India, in Pune. And Cisco, you may have heard of, is a networking provider. They had a very simple idea, and that is if you could track every person, every part, every work in progress, and every tool on the factory floor, you could do two things. You could make the factory floor more efficient because you'd know exactly what part of the factory is in use and what is not in use, and because you know what's coming in and what's going out at a much finer grained level, very much like precision agriculture. Second, and because unions were involved, it also makes the manufacturing floor safer. The system knows if somebody picks up a tool and he has not been trained to use that tool, he will be told, please put the tool down, you haven't been trained, and provide training immediately. It shows him how to use the tool. It also makes sure that he doesn't leave the safe area with the tool. It's geofencing, as that's called. Very simple idea. They use the technology from Cisco to triangulate using Wi-Fi to know where everything is in the factory, and they track everything, even the people. This has been tremendously successful. We'll be announcing in the next few weeks a new project to open source their results and also to create open standards around that open source. They're going into a second phase now in which they want to be able to know that this bolt is being put in the right hole on that part. That requires much better precision, much better than what they can get from Wi-Fi triangulation. Wi-Fi triangulation gives you about 1 meter resolution. They need 3 millimeters. If you have any ideas, let me know. That's in Germany and in India. The second one we announced is actually in Ireland. It's in County Cork, a region, a province in the south of Ireland. Very simple idea again. Connect together all of the information technology in County Cork. And if we did that, what could we build on that test bed? The first thing they're building is an integration between the National Health Service of Ireland and the ambulance services. This just went live 2 weeks ago. Now when the ambulance arrives at your door, as long as you have told the ambulance, the dispatch people, who you are, who you're coming for, they already have your health data on the ambulance. It's been uploaded directly into the ambulance. So if you have high blood pressure, if you have Alzheimer's disease, if you're diabetic, they know before they arrive, and they can start treating you correctly immediately. And their treatment is uploaded directly to the hospital, so when you arrive at the hospital, they already know exactly what the problem is. This will save lives. It will save money, but it will also save lives. And it's a very simple idea. The starting point was trivial, just putting a GPS tracker on every ambulance. Here's one of my favorite stories about big data giving you opportunities you didn't know existed. The first thing they did was put these GPS trackers on the ambulances, and they discovered, they get a ping from every ambulance every 10 seconds, they discovered that ambulance drivers were spending too long in the coffee shops. I'm consulting on this project, and I was in Ireland, and they said, what should we do about this? Because if we say anything to the ambulance drivers, the unions will be furious. I said, you should congratulate them and get them special parking spaces at the coffee shops. Not a joke. The whole point is dispersing the ambulances throughout the county so that there's always an ambulance near my house when I'm in trouble and near your house when you're in trouble. So it's a good thing. In fact, I said, buy them parking spaces near the coffee shops. In fact, I said, use the data that you get so you know where all the calls are now, near the dangerous traffic intersections, near the old folks' homes. Wherever you get most of the calls, go buy parking spaces for them near those coffee shops. Don't bring them back to the hospital. Don't bring them back to the depot. Disperse them wherever the problems are in the county. And now you can do it because you know you have geographic data on where the calls are from. You have geographic data. You know where the ambulances are. You know where the hospitals are. You can optimize far better than you could before. They were very happy. The unions are also very happy. The coffee shops are delighted. So I'm running out of time. I will say we now have 9 public test beds. They're on our website. You can take a look at them. They're in predictive maintenance. They're in high-speed networking. Let me give you an idea about the high-speed networking. I can't say too much about it, but think about what you could do if you got healthcare data from the health apparatus on patients in hospitals all over a big country. I don't mean large population, I mean large country geographically, so I mean Chile. And you want to track population health issues, disease, as they move across a country. You could not possibly do better than do that by anonymizing and aggregating health data from patients all over the country, and you can track the movement of health issues, population health issues. Not a bad idea. Amazing what you can do with that kind of information. Our asset efficiency test bed is focused on best using the assets in a manufacturing site, best using the assets in an agricultural situation, for example. And before you laugh at agriculture, you should look at Mario's results, but I'll give you another example. We do events actually on Internet of Things adoption in industrial systems all over the world. Last year, I gave 40 keynotes in every corner of the world. And my favorite talk is by a guy who got his undergraduate degree from MIT. He moved back to Costa Rica. He worked for 30 years there as the head, eventually the editor-in-chief of the largest newspaper in town, La Nación. It's kind of like Mercurio here. And then he retired to open a dairy farm, una lechera. And he now churns out 40% more milk than his neighbors. With the same cows, in the same land, 40%. How does he do that? He tracks all of his cows' health, everything about their health, every minute of every day, and differentially feeds them. and differentially milks them as well. So I don't know much about cows. I learned it all from him. But I do know that they weigh about 600 kilos and they eat 60 kilos a day. 60 kilos a day. I would love to eat 60 kilos a day. And their health varies based on as little as 1 gram of differential in the feed. 1 gram of differential. So he differentially feeds them and he gets 40% more milk. Same cows, same land, 40% more milk. That's 40% more revenue. That's that excess value, not just perceived value like you heard from Don Ivan, but real value from those cows, or as he calls them, my girls. All of these things are not new technology. They are a convergence between operational technology and information technology. What you heard from Don Ivan, 50,000 million connected devices in the world, I don't care if that number is right or wrong. That's not interesting. In fact, I think the number is much higher than that today. Every cellular, every mobile phone in the world is already a connected device. It's tracking you. It typically knows the temperature. It often knows the speed. And eventually it will know your blood pressure. Those are connected devices today. I argue that every MP3 player in the world is already a connected device. I think there are probably hundreds of billions, hundreds of thousands of millions of connected devices today. But I don't care. What I care is, can I use that information in an interesting way? And now I have the technology to make that happen. Big data technology is easy. It's free. You can download Hadoop and use it today. You can rent the computing power from a cloud. You don't have to buy computing power and put it in a data center. There are plenty of data centers. Where are the data centers? I don't care. They're anywhere, as long as I have a connection to the data center. The opportunities are everywhere. The opportunities are applying information technology to industrial systems, far more than anything else. So here are some examples. I'm just going to talk about 2 of them. On the left, that is a jet engine. Anybody interested in jet engines at all? Well, you're going to have to be, because I love jet engines. Jet engines are magical. Actually, airplanes are magical. Do you know how airplanes work? They work by magic. Yes. Actually, I know, I'm an engineer, I told you that. I know exactly how engines work, how airplanes work. And that is, the air goes against the wing, the air is then pushed down by the wing goes up. That's it. Anybody that tries to tell you anything else like the Bernoulli principle, he's an idiot. The air, and if you don't believe me, the next time you're on the highway, stick your hand out like this and tilt it upwards. Your hand goes up. Tilt it down, your hand goes down. Jet engines, a little bit more complicated, but not much. Jet engines are rockets with a hole in the front and the back. Really what they are. If you could track a jet engine every minute of every day, you can do a much better job of getting efficiency out of that jet engine. But the manufacturers, who are the people that have all of the information about those engines, General Electric, Pratt & Whitney, Rolls-Royce, CFM, Avic, and so forth, they typically don't get information from those jet engines. Why not? Because they don't own them anymore. They sold them. A manufacturer sells to a wholesaler who sells to a value-added retailer who sells to another retailer who sells to a distributor who sells to another retailer, and by then, nobody has anything unless you send back your warranty card. Who sends back warranty cards? Good, smart people. Nobody sends back warranty cards. I usually get one person, I send out warranty cards. So there's no connection between the user of the product, as you heard already twice today, between user of the product and manufacturer of the product. So General Electric and Rolls-Royce both had a very clever idea. They said, you can buy an engine from us the same way you always used to. We'll sell you the engine for 80% of the cost of the engine. 80%. Why? Because for the next 40 to 50 years, we'll sell you spare parts 5 times the cost of the engine for the next 40 years. That's where we'll make our money. Or, both Rolls-Royce and General Electric say, if you want, we will lease you the engine. We'll rent you the engine. In fact, we will lease you not on an hourly basis, but we will lease you that engine for a certain number of tens of thousands of pounds of propulsion for a certain number of hours and guarantee a certain amount of fuel use. I call it propulsion as a service. It's what it is. And if you use more fuel than that to go that much propulsion for that many hours, they will pay for the fuel. General Electric even has a deal where the amount of fuel guarantee drops by 1% every year for the life of the lease. So I get to pay for it as an operating expense rather than a capital expense. None of you are accountants, so you don't care, but trust me, it's a good idea. And it also means now the manufacturer of the engine has detailed, real-time information about that engine and can and will guarantee that it is kept in perfectly efficient operating order. Tremendously valuable. Huge opportunity. Let me talk about this one more opportunity, then I promise I'll shut up. Anybody know what that is? Anybody recognize that? Only the older people in the room, yeah. This is called a pulse oximeter. It clips onto your finger, and it looks through your skin, and it guesses how much oxygen is in your blood. So if you've ever been in surgery, they had one on your finger. They were checking to see, is there enough oxygen in your blood? Are you breathing properly? Guess what? When I say guessing, I really mean it. Only 80% of the readings are any good. Because we have different color skin and we have different thickness of vascular walls, it really is only guessing. The other, even worse problem is if they also have an automated blood pressure cuff on your arm, when the blood pressure cuff blows up, it stops the blood flow into your arm, and the oxygen in your blood goes to 0. And an alarm rings at the nurse's station, and the nurse says, it's just a pulse oximeter, it's probably wrong, and ignores it. There are too many alarms in hospitals. It's one of the problems that hospitals have. And nurses, especially in intensive care units where they have dozens of patients, nurses will ignore 1, sometimes even 2 alarms from a pulse oximeter, because after all, you have 4 minutes. And they know that people make mistakes with blood pressure cuffs. You're never supposed to put the blood pressure cuff on the same arm as the pulse oximeter, for the obvious reason. Why not connect the blood pressure cuff to the pulse oximeter? So when the blood pressure cuff blows up, it sends a message to the pulse oximeter and says, by the way, I'm cutting off blood flow, so stop measuring for a little bit. Isn't that obvious? There is no manufacturer anywhere in the world that makes both blood pressure cuffs and pulse oximeters. And do you know how many places the pulse oximeters and blood pressure cuffs are connected in the world? 0. Only in 3 laboratories that I've run into, one in the States, one in Germany, one in Japan. And this is only in research laboratories, not in real hospitals. So in the meantime, there are unexpected alarms, and alarms that may be ignored, and there are deaths. People die because of this. It's a real serious issue. Because the only good news is if you ignore this for more than 4 minutes, if you don't have oxygen in your blood for more than 4 minutes, you don't have to worry about anything ever again. It's just to get you to laugh, to try to relax there. So. There are enormous opportunities. I hope you get the feeling from the talks that you heard this morning that these are specific opportunities and they are opportunities everywhere in the world. And I hope that these are some examples that you will follow up on. This is how to contact me. I'll be here for the rest of the session today. This is how to contact me if you think of something later. If you Google Richard Soley, I'm the only one that shows up. All the other ones are liars. And I apologize for the photograph which was taken 35 kilos ago.